Welcome back to Startup Hack. With my 25 years of development experience, here at Startup Hack, we turn beginners into full-stack developers in as little as 3 months. Today, we're diving into some more basics of C#, a versatile and powerful programming language that's essential for any developer's toolbox. So whether you're just starting out or looking to refresh your skills, we're going to go through some basics, but some good review concepts, and to help you understand the syntax to write your code. So stick around, and I love if you ask questions down in the comments, but let's get started. All right, so like I said, we're going to be starting off with some basics. So if you're really more advanced, check out this link here above that I should be putting up here somewhere. And in that link, I give you a lot more, the playlist for a lot more advanced stuff. We have hundreds of coding tutorials and also make sure you download the code samples down below because we provide hundreds of different projects out there. All of our code is runnable, it's all been tested, and we run it. And so make sure you pull down this code because we have hundreds of different code samples. We actually have 2 different repositories. That's hard for you to say. But so make sure you check those out. All right, let's dive in here. So today we're going to talk about enum. Enums are really helpful because they allow you to be able to define things where you can reference these via number. You notice as I hover over them, it says, hey, the day of the week is 0, for Sunday is 0, and as Friday it's 5, right? So this enums are stored as actually a number, but given then a string value to them. So in this case, we can say days of the week, and we can then use Wednesday instead of having to use number 3. All right, so that's what an enum is. Now, an interface is actually a keyword that we use, and it is the framework of a class without actually the implementation of a class. So this is how we do inheritance inside of C#. So we build an interface called iVehicle, and then from iVehicle, you can have lots of different type of vehicles. So in this case, we have car, but we could do truck, we could do semi, we could even do like motorcycle, and then you can say start and stop, right? And then this is how you would then implement, and each one of these classes that inherit the interface have to implement those methods. So this is how we do inheritance, and also how you can even do multiple inheritance with C# is using interfaces. All right, we're going to talk a little bit about a class. So a class is how we declare an object. So in this case, we create an object of a person, and that object is going to have properties, name and address. It's also going to have a method called introduce, which when you call the introduce method, it'll say, hello, my name is this, and age is this, right? So this is a method that's on this person class. And we're burning through these really, really fast here, but you can see the use case, right? So we'd say person, and they use the new keyword, person, and then your curly braces, and you can then declare these objects. Also, you can reference these as person.name, right? And this would, capital N, name, and then give them the name. This would actually overwrite Alice and say, Alice Cooper. I bet you were thinking Alice in Wonderland, right? Don't forget your semicolon. All right, so this would then call that method on the object to write this, right? So if we ran this here, and then we did person.name equals Bob, and then we ran this again, we would actually see that it would change to hello, my name is Bob, and I'm 30 years old. All right, you get the drift. All right, now a record is kind of like an object. It takes in these principles, and then it actually is stored on the stack instead of on the heap. So records are very handy to use as a data transformation object when you're passing data around. Again, I'm burning through this really fast because I don't want this video to be 60 minutes long. All right, a struct. A struct is similar to a record, but slightly different because in this case, we would use the point, and then this is immutable, meaning it can't be changed. A record can actually still be changed, is some of the differences. We also have a dynamic object, which says dynamic value of hello world, and then as we write the value, there's no compile time checking, so you can assign anything to it and make it like JavaScript and like the Wild West, right? Because then we can change this and give it a 42, right? So the type can even change at runtime. I'm not a huge fan of these. There are certain use cases for them. I think that this breaks type safety, but we'll just kind of keep moving on. Let me know if you think otherwise. I love a good, healthy discussion, but if I saw a whole bunch of code written with dynamic variables, I would probably call foul as a manager. or doing a code review. All right, lots of different things here. I'm gonna let you pull down the code samples of these because, man, this will take us forever if we go through all of these, and this video will be crazy long. All right, string manipulation. This is huge, right? We have concat, which allows you to combine two strings. We have join, which will take different elements. We can do split, where you can split at certain places. Two upper and two lower, pretty obvious, right? You want to convert something to uppercase and lowercase. We have lots of different file I/O classes. This is one of the amazing things about C#. Very easy to work with files, so you can read all the text from a path, write all the text to a path, and then check even if a file exists, right? So lots of great things. Date and time objects. This allows us to then work with these date times. We take this and parse it out, so you can take a string and parse it into a date object. You've got your .now, which you'll use very frequently. And then you can even do some date math here. C# is very, very good at date math. Sometimes parsing strings to dates can always be a little interesting, but that's how we roll. All right, generics. So because C# is a type-safe language, we want type-safe data structures, right? So in this case, we have a stack of type T, right? And this is commonly how you'll see it written. We then also want to see a list of type T, right, which is an object on this class. And then we can push an item onto the stack, right? We would then pop the item and remove it from there. So this very simple stack class implements push and pop. You can see with just, maybe 20 lines of code. So very handy, very great stuff to use. And then as you can see, obviously we would use the stack class, the stack, because we're going to push it of type T, right? So this allows us to then decide what type of a stack we want. So if we wanted a stack of integers or strings or whatever, then the compiler will decide these at compile time, and we can make sure that we stay with our type-safe language. This is good stuff, right? All right, nullables. I think I mentioned this in one of the first video. You take this and you add a question mark to it, and it allows you to then have a nullable object. So in this case, an integer that can actually return null, right? These can be very handy for Booleans. So Boolean can be is true, false, or not set, right? And you can actually assign it null. Very handy. It allows you to basically know if that, a lot of times you'll see stuff where without this we have to set either true or false. And so you'll see it default to false, but really that's kind of a false because it actually hasn't been set in a lot of cases. So this is where nullable types come in really, really handy. And C# nullable types are fantastic. Let's see here. We're still cruising right along because, man, we're burning through this. So like I said, love to help developers. Check out the course. If you have somebody who's doing this because it's their first time, I would definitely get them more help than just this video. This is a great introduction to some principles, and then we can dive into even further if they want to jump in the course. All right, attributes and reflection. So in this case, we have an object called person. We can take this person and say, hey, what type of class is this? We can then get the properties and store them into an array. You can loop over them. This allows you to use reflection to see what types and things are on this class. So this gives you the metadata and type to be able to introspect onto a class. So as a type-safe class, we can use that to our advantage. We also then have extension methods. These are super, super handy. Let's say that you want to change to uppercase. Seems like kind of a weird one to change, but if you want to do this, you could then take this string and then do the to upper. And then the way you would use this is if you use this one, it's going to use the extension method instead of using the built-in to uppercase. So again, this is called to uppercase instead of to upper, but it's kind of a silly example. But extension methods are great, and you definitely will see extension methods. Boy, hard for you to say. All right, dependency injection. Definitely something you're going to see a lot is dependency injection. So we have our interface of iLogger, right? And logging is definitely one of these scenarios where we see DI or dependency injection being used. We would then log a message, right? This is where it needs to implement it then, right? So then in the my class, we would grab the iLogger method, We will then call the constructor here, right, and passing in the iLogger, and we'll set our logger equal to that. I think we may have forgotten, yeah. So then in this case, if we do something and we want to log, see now we can hit this underscore logger and we'll have passed in that iLogger method. So we then need to implement the iLogger interface, right? And we can create a console logger class, which will do this work. These are very handy. You're going to do a lot of DI. In order to do dependency injection justice and teaching you, we'd have to do a whole video on it. But check it out because, like I said, tons of code samples. Pull those down. You'll see lots of dependency injection examples. And I know I've done some videos on it in the past. All right. Myself or one of my instructors. This next one is called a partial class. This allows you to then use the partial class multiple times. So you can do a my class and do partials. This used to be a bigger thing than it is now. I don't really use partial classes a whole lot of times, but you can split a partial class across multiple files. All right, interoperability. If you have an old DLL, again, you're seeing this less and less anymore, but you get a third-party DLL that has an SDK. A lot of times you may see this with like an interface if you're interfacing against some type of an object that's using COM or using some old scanner or something like that. Or you've got some old DLL that you need to use inside of here. You can do the DLL import of this DLL and the path to it. We can then call against that interface and use some of those methods, right? And so this is how we do interoperability against some older DLLs. Carefully, you'll get yourself into DLL hell and some of that. All right, we got anonymous types, right? So I can say, hey, var person equals new. What this is going to do is the compiler is going to figure out what this type is, right? And it'll figure out that it's an object that has those properties. And then you can then use that object with those properties. This is very handy. You'll see this especially as you're manipulating data a lot of times. Tuples, right? So we get a tuple here, and this tuple where we say string name. These look fairly similar, but then you pass in Alice and the 30, and then again, similar way that you can use it. So we access these elements using item 1 and item 2. All right, pattern matching, right? So pattern matching, if you have an object and you say it's like this, right? And if the object is person, and you check this and say they're great, we can actually do a pattern match on an object based on various properties. Local functions, right? We're really cruising through these here. So we want to encapsulate logic within a method here, right? And so this is our main method, and we can call the calculate. So we get a public static calculate class, and this is easy if we don't want to get into like creating an object and then setting the method on that object. So if we do this, we can see that this calculate method here allows us to then, creates this local function inside of this method, right? And so this local method was going to call this method. So you can see this being called, factorially. Again, burning through these. We talked a little bit about records before. Here's another example of records where you can then compare records as one of the big advantages here. We can see the with expression, right? So John with this non-destructive mutation. Look this up. This is a little bit more complex than I'm going to dive into at 13 minutes in the video. Lots more here, and I don't honestly know that we really have time today to go through all of these. These videos get really long. So pull down these code samples, try them out in your own Visual Studio. If you have questions, of course, leave comments here. If you think, man, Spencer, I ever wish you'd really finished out this video, let me know. I'd love to get the good feedback. Here at Startup Hack, we love to train software developers. So with my 25 years of development experience, I love to teach how to code. That's why I have this channel. So make sure you like and subscribe, and make sure you pull down those code samples, and we will catch you guys next time. Make sure you like and subscribe to the channel because we bring you lots of great tutorials and tips that every developer should know. See you next time.